Hello, my name is Keshwani, that's K-E-S-H-W-A-N-I, Keshwani. In these clips that I've been putting on the YouTube, I've been working on math problems that you will find in the official SAT study guide. I will try to do as many as I can and I'll put them on the YouTube. Of course I do math clips, but in person when I tutor somebody, in person of course I help with the entire SAT, the reading part, the writing part and the math part. The reason I decided to do only the math clips for the time being on the YouTube is because they are easier to start out with. To try to figure out the reading problem, the passage or the parts dealing with the grammar or sentence completions on the YouTube is a bit tricky. Math is more straightforward, so I'm doing that right now. Anyway, right now I'm working on exam number 3, section number 2, page 521, question number 14. That is the notation that I use. So if any time you want to search for a given problem, you know what notation to use there. If after watching the clip you find it helpful and you decide to buy the whole DVD that will contain the solution to all the problems, all the math problems that appear in the section number 2 of exam number 3, all you have to do is send me an email through this website, prep4SAT.com. Let's get going then. Enough of the talk. It's important that you have the book in front of you, otherwise you will not be able to follow it. It says for how many ordered pairs of integers, positive integers, they have to be integers, they have to be whole numbers, and they have to be positive, so that this quantity that we see here is going to be less than 6. Let me first talk about what does it mean, what does an ordered pair mean. Ordered pair is basically coordinates of a point. In this case, that is. For example, let me erase this for a second here. Let's say, for example, you're told that we are looking for positive integers and they have to be less than or equal to 5 for x. Say, for example, we are told that x has to be less than or equal to 5. It has to be a positive integer. It has to be a positive integer, and let's say we're told that y is equal to less than or equal to 3. I'm just giving you an example. You understand? It's nothing to do with this problem. I'm just trying to make you understand what an ordered pair means. So in this case, we know that the values of x that we can have are 1, 2, 3, 4. Let's keep it until 4. Keep it simple. And let's keep it at 2. Let's see how many ordered pair are we going to find. We are going to find altogether 8 ordered pair. 4 times 2. And I'm going to very quickly make a list of all 8 ordered pair, which is why I reduced the 4 to 5 and from 3 to 2, so I can... Otherwise, if we had a 5 here and 3 here, we would have had a 15 ordered pair. I'm going to list all of them very quickly. 1, 1, 1, 2, 2, 1, 2, 1, 2, 2, 3, 1, 3, 2, 4, 1, and 4, 2. Let's talk about this very quickly. how is this ordered pair different from, let's say, this one? Well, they're different, they're not the same. The order matters, which is hence the ordered pair. Order matters because here we're saying x equals 2 and x equals 1 and y equals 2. Here we're just saying just the opposite, x equals 2 and y equals 1. Similarly, as you can see, 3, 1, where did I put 1, 3? 3, 1. Oh, actually we don't have 1, 3. We don't have 1, 3 because y cannot be 3. So they are different, as you can see. You see? That's the only example I can show you here, because we have 4, 1 where x equals 4, y equals 1, but we don't have 1, 4 because we can have x equal to 1, but we cannot have y equal to 4 because y in this case is less than or equal to 2. But as you can see, they are different. These two are different. The question simply is, in our case, all we are told is that we have ordered pair which are positive integers. How many of them are possible so that this quantity 2x plus 3y is less than 6? Well, let's begin logically. Let's do 1, 1, 1, 2, 1, 3 and so forth, and then we'll do 2, 1 and so forth, 2, 1, 3, 1 and so forth. We'll just continue. And where can we stop here? 1, 1, 1, 2, 1, 3. Where do we stop? I don't know where. 1 and maybe 20,003,400. I don't know. There is no values assigned to it. So question is, how many ordered pair are we going to have? We'll see. Let's try 1, 1. If I put 1, 1, x is 1 and y is 1. 3 times 1 is 3 and plus 2 is 5, which is less than 6. This one works. What happens if I do 2, 1? Let's try 2, 1. If I do 2, 1, which is x is equal to 2 and y equals 1, I'm trying 2, 1 now. So this one works. Let's try this one. This is the one I'm trying next now. Let's try this one here. Right here. 4 plus 3 is not less than 7. This guy does not work. Let's try one more. How about 1, 2? Did we try 1, 2? Let's try 1, 2. As you can see right away, if I try 1, 2, when I put 2 here, this is going to be 6 plus 2 is going to be 8. 1, 2 does not work. I'm trying right now this one. I'm trying this one right now. 1, 2. 2 times x, which is 1, plus y, which is 2. 6 plus 2 is 8, which is not less than 6. This does not work either. Similarly, 1, 3 is not going to work because as soon as you put a 3 here, you're going to end up 9, which is not going to be less than 6. 3, 1 is not going to work because as soon as you put in 3 here, it's going to be 6. And then you put a 1 for y, it's going to be 3 here. It's not going to be less than 6. There are no other ordered pair. Only one ordered pair will satisfy this condition where 2 times x plus 3 times y is going to be less than 6. And that ordered pair is 1, 1, right here. So the answer is 1. There is only one ordered pair. Excuse me. The answer is A. A is the answer. That's it. Quite simple and straightforward. But then again, this was question number 14, which is a medium question. This is not a hard question. This is not one of the last 3 or 4. Anyway, that was the solution. Send me comments. Subscribe to my channel on the YouTube if you find this helpful. That way you will get the videos right away. And I'll see you in the next clip. And get hold of me if you wish to hire my services to tutor you in person. I'm located in Connecticut. And of course, I'm willing to go anywhere to help you out as long as we come to some agreement. But I'm located in Connecticut. And that's the website, prep4sat.com. Thank you.